All right, welcome again. All right, so after the video, you should be able to do this. Calculate the atomic mass when provided by percent abundances and atomic masses of isotope, and also compare the relative abundance of isotopes for particular elements. Okay, so, all right. So just a little bit of remembering. Mass number equals protons plus neutrons. This is your this is your man part, okay, of 8-man, and part of 8-man. Isotopes, atoms with different number of neutrons, but remember they are the same element. Okay, same element. This is what we're going to focus on today. Atomic masses occur with decimal points because they are an average of different isotopes. My pen is not working real well. Sorry about that, guys. So, how did we get to the average of the atomic mass units? It's defined as the 1/12 of the mass of a carbon atom. Carbon is used to date everything in the world, basically. So carbon is like one of our main foundations of elements. It's our main element. Everything's based off of carbon-12. The way that atomic mass is measured is on the periodic table, and it's abbreviated AMU, atomic mass units. Okay, so to find the atomic mass, you'll need to know these three things. So write these three things down in your journal, and it's right there. So we need to know the number of isotopes, stable isotopes. We need to know the mass of each isotope, and we need to know the natural percent abundance of each isotope. So here's a real-world application of how we use it. Okay, so for instance, let's pretend well, we're not going to pretend, these are our averages. You get 40% for tests, 30 for labs, and 30 for dailies. If you made 80 on your test, and you made 100 on your labs, and 40 on all your dailies, and you wanted to know what your grade was, well, first you take your percentages and divide them by 100, and you get a decimal. So you get 0.4, 0.3, 0.3. Okay. Then you're going to take and you're going to add them. Multiply those percentages times what your grades were. So 40% was 80, plus 30% at 100, plus 3% at 40, and you end up with 32 plus 30 plus 12. So your final grade would be a 74. That is how it's used today. All percentages must equal 100 when you add them together, and all decimals should equal 1 if you are going to add them together. So 0.4, 0.3, and 0.3 do equal 1. 40%, 30%, 30% is 100%. You will need this formula in your journal because this is what we're going to use. When it has these three dots, just remember we can keep going. If we have 3 isotopes, we'll add another one. If we have 4, we'll add another one, and so on and so on. All right, so let's do an example. If you watched my Guess You video, which you should have, because I'm going to tell you need to watch it before this video, we're going to do how I would do my problems. First thing I'm going to do is I'm going to go and I'm going to circle all my given numbers. Every number that I see, I'm going to circle. Okay, I'm going to label. This is my this is my isotope. Sorry, my isotope 1, my isotope 2. Isotope 1 has 75%, so that's my percent. Isotope 2 has my second percent. Okay. Now I'm going to underline calculate. Excuse me. So we're going to substitute in. So I'm going to do it over here. So I substituted in all of my numbers and put it in my formula because I found my formula was isotope 1 times the percent plus, don't forget your parentheses, your isotope 2, times your percent equals. Okay? That's an I, by the way, over here. Sorry, this is an I. I don't know why it's not showing up. Isotope 1, isotope 2. Okay? So I plug it all in. I do the math. I get 26.59, and I get 9 plus 9.323. Okay. I'm going to add it together, and I'm going to box in my answer, and I'm going to put in my number. So there's my guess you. So I get 35.91 AMU. Let's try another one. what if you don't have the percentage or the atomic mass of one of your isotopes? Well, again, we're going to go ahead and we're going to circle what's given. And I'm going to circle 114.82. And one isotope, okay, is going to have 114.90 at 95. So I'm going to label, this is my AMU, or my atomic mass. Okay. This is my isotope number 1, and it's percent. It says calculate the atomic mass of one of indium's isotopes. So we only have one, we need the other. There's my question. So I'm going to go ahead and substitute in, and I'm going to try to solve. So here's what's given, okay? But one of the things I know that I can do is, this is for isotope number 2. If I know I have 95.79%, it has to equal 100%. So how do I find my percent of number 2? Well, I can take 100 minus 95.79 and I get the second percent. So this is isotope number 2's percent. Okay. So I can find my equation, and again, my equation is atomic mass equals isotope number 1 percent times percent plus isotope number 2 times percent. Okay. So we're going to go substitute in, and let me get rid of this real quick. Okay, we're going to substitute in. So I plug in my values, and I plug in my values, and I start multiplying these two. I multiply these two, and I get 110.07. I multiply these two, and I get x times this, or when you come back, you end up with 0.0421x. Now, the reason why this is subtracting, remember we want to isolate the x, or we want to put the x on one side. So we're subtracting like terms, and you end up with 4.75 equals the 0.0421x. So you divide by the 0.421, and x equals 113 AMU. Okay, we'll do some more of these in class. But this one is a little bit more challenging, but just remember, and I'm going to go back a little bit, just remember your equation, okay? To calculate atomic mass, so it's atomic mass equals the isotope of number 1 times your percent plus the isotope number 2 times percent, and so on, plus so on, so on. Okay? So I'll see you guys in class.